All right, welcome guys. We're going to be going over lesson 4.2, talking about fractional exponents, so exponents that are not whole numbers, specifically ones that can be written as a fraction. Today we're going to introduce this idea and extend this knowledge about exponents. So basically it's really important to know that all of the exponents apply, all the exponent rules we've talked about before, when we multiply exponents together using the product property or add them together, they are going to continue to apply when we talk about fractional exponents as well. So, some previous knowledge here that we have, the product property, right? When we have x to the third raised to the fourth power, right? That exponent on the outside is telling us how many x to the thirds we have that are all multiplied together, right? So we have 1, 2, 3, 4 of those that are all multiplied together, and then our addition property of exponent tells us to add those. Get that, right? The shortcut, the law, or the rule is to simply multiply these exponents together 4 times 3. We'll make use of that shortcut and the expanding as we move through. So here we're going to look at this first exercise. We're going to recall the product property of exponents, kind of remember what to do here. So we have 2 to the third to the fourth power, right? The rule, we can see it right up here, the law. As long as that base, is being raised to a power, right? And we're raising that to a power, we're just going to simply multiply these exponents. So that's 3 times 4. 3 times 4 is 12. You don't actually need to multiply that out. That actually would be a pretty large number if we raise that to the 12th power. Going ahead and moving forward, again, using that property here, we're multiplying these exponents. So we're doing -2 times 5. That's going to give us an exponent of -10. Now remember, negative exponents can be represented differently. We can write that as a fraction, so 1 over 5 to the 10th. Right? That's something we can always do with negative exponents. Let me go ahead and write that rule out here. B to the negative n can always be written as 1 over b to the n. That's how we can deal with negative exponents. Okay. Second thing here, or third one here, letter C. Again, multiply those exponents together. 7 times 0. Anything times 0 is just 0. And then we have this property of what do we do when our exponent is 0, right? So we define that to be equal to just 1. That's just the rule here. So any base to the 0 power is just going to equal 1. That's it. It's just the way we define that. Again, that's for 0 exponent. Okay. Moving forward, looks complicated, but we just, again, we have a power to a power to a power. We're just going to multiply all these together. So 2 times -2 times 2. That's going to be -8. And again, dealing with negative exponents, we can rewrite that as 1 over 4 to the 8th. No need to actually multiply that out. And there we go. Quick review of the product property of exponents. Next thing we're going to do is we're going to use the product property to extend our understanding of exponents to include what's called the unit fraction. Exponents that are written as 1 over n, where n is a positive number, whole number. Quick note on how fractions work. Well, I mean, the number on top, right? Number on the bottom. Whenever we have a unit fraction, this will never be able to be simplified, but for other fractions, say we had something like 3 over 6, right? This is not a unit fraction. Unit fractions have to have a numerator of 1. So this could simplify, right? We can divide both the numerator and the denominator by 3, and that would give us 1/2. So we're going to be focusing on fractions that can be written as unit fractions, so like this one here. All right. When you multiply an integer, a positive or negative whole number, by a unit fraction, it's the same as dividing that by the denominator of your unit fraction. So right here we have 5 times 1 over 5. This is the same thing as doing 5 divided by 5. very simple process, something that's quite useful to know. So in this case, we get the answer of 1. Same thing going on here. 6 times 1/3 is the same thing as doing 6 divided by 3, right? Which is 2. Or negative 12 times 1/4 is same thing as negative 12 divided by 4, which is negative 3. And then 8 times 1/2 is the same thing as 8 divided by 2, which is 4. Really important kind of shortcut skill to remember and make use of. So let's consider the following expression, 16 to the 1/2 power. What does it mean to be to the 1/2 power? I mean, we know that 16 to the 0 power is equal to 1, and we know that 16 to the first power is equal to 16. And 0 and 1, we have 1/2 that sits right in between that. So what would 16 to the 1/2 power be? A lot of people's inclination would be to maybe guess that it's equal to, kind of halfway in between those numbers, but turns out it's not. Let's actually take a look at it. So it's important to remember that 16 can be written as 4 to the 2nd power. That's just simply another way to write that, right? That's pretty easy to write. So rather than writing 16 to the 1/2, we can rewrite that base, right? So 16 to the 1/2 is the same thing. It's equivalent to 4 squared to the 1/2. And that's because 4 squared is equal to 16. 4 times 4 is 16. So I'm just writing it in a slightly different way. And now what you notice here is we have a situation where we can apply that product property of exponents, what we kind of started off with before, right? We're supposed to multiply these exponents together. We're supposed to do 4 to the 2 times 1/2. And we just look, right? What happens when you multiply by a unit fraction like this? It's the same thing as dividing. We're doing 2 divided by 2, which is 1. So this is the same thing as 4 to the first power, or simply 4. So what we're saying is this. We're saying 16 to the 1/2 power is 4. That is the same thing as doing the square root of 16. It's also 4. So it turns out raising something to a 1/2 power is the same thing as taking the square root of that number. Square root. This example gives us 2 pieces of information we can use in simplifying fractional exponents. We can rewrite the base as a number to a power, and you can divide to simplify. So kind of a cool thing here. So in our case, we're going to be looking at 8 to the 1/3 power. You can kind of follow through right here. I'm going to rewrite that and kind of talk through what's going on there. So 8 to the 1/3 power. Well, turns out we can rewrite this base 8 as 2. We can rewrite it as 2 to the 3rd power. That's equivalent to 8. 2 times 2 times 2 is 8. Well, 2 to the 3rd raised to the 1/3, that's the same thing, right? This is the same thing as 8, and it's being raised to the 1/3 power. And now we make use of that product property again, right? Product property says, hey, just go ahead and multiply these exponents. Multiply 3 times 1/3. We're multiplying by unit fraction. We just get 1. So 2 to the 1, or simply 2. Kind of weird. 2 to the 1/3, or 8 to the 1/3 power is equal to 2. What in the world's going on here? Turns out it's equivalent to the cube root of 8. The cube root. Cube root because we're doing 1/3. Previously, this was square root because we were raising to the 1/2 power. So square root is 1/2 power, cube root is 1/3 power, and we'll kind of see what's going on there. Again, right? You can see right here. An exponent of 1/2 is equivalent to taking the square root of a number. Wild, something that's pretty cool, actually, when we really get into it. So let's go ahead and look through some of these examples here. So we're going to test some equivalences. We're going to do 25 to the 1/2 power. We're going to actually do this both by hand and using a calculator to kind of demonstrate that. So 25 to the 1/2 power, 25 can be rewritten as 5 squared. So this is the same thing as 5 squared to the 1/2 power. And then when we apply that product property of exponents, 2 times 1/2 is 1. So 5 to the 1 power is just simply 5. Let's just double check this. Let's see what's going on here. Square root of 25 is 5. 25 to the 1/2 power, also 5. Works out. Pretty crazy. Raising something to the 1/2 power is the same thing as taking the square root. Again, let's go through a couple more of these just to verify that. 81 to the 1/2. This is going to be 9. The square root of 81 is 9. We can double check that on the calculator. Square root of 81, it's 9. But let's go ahead and talk about why this works, right? 81 is 9 squared raised to the 1/2 power. We multiply these two exponents together. 2 times 1/2, we get 1. So we just get 9. And it's the same, right? And the last one, 100. Hopefully we know, but let's just double check it. Square root of 100 is 10, right? It's 10. Well, 100 is the same thing as 10 squared. And we're raising this to the 1/2 power. Product property of exponents says, again, to multiply these exponents, 2 times 1/2 is 1. So we just get 10. Pretty cool that raising something to the 1/2 power is equivalent to square roots. Now, we can extend this, right? This is only one specific exponent of 1/2. Turns out any unit fraction like this, 1 over a number, is equivalent to taking all different types of roots. So square roots is 1/2, cube roots is 1/3, fourth roots is 1/4, fifth roots, etc. Right? We're not really going to dive into too much more than maybe the occasional fourth root. You know, not going to have us taking like 19th roots of anything. So anyway, if we have some number, b to the 1 over n, that's the same thing as taking the nth root. So let's look at that as an example. If we do 64 to the 1/3 power, that's equivalent to doing the third root or the cube root of 64. Those things are equivalent. In this case, that actually equals 4. Another example, just quickly write this one down. Let's say we're doing 32 to the 1/5 power. That's the same thing as taking the 5th root of 32. What number multiplies by itself 5 times to give us 32? Turns out that number is 2. Now, not all roots or radicals like this are going to have nice whole number answers like we came up with there. In fact, most numbers will have to give decimals. But yeah. If you want to use your calculator to do some of these roots, you certainly can. You have to press the shift button, and then right here, it's hard to see it, but in orange above this, there's a little radical symbol with an X on it. If I press that, it'll give me the ability to type in any sort of root. So we'll do the 5th root of 32 and see and confirm that that actually is 2. All right. So let's go ahead and rewrite each of the following roots instead of rational exponents. And then if necessary, we'll use our calculator to evaluate them. So 125 to the 1/3 power, that's the same thing as the third root of 125. Hard to know what that might be. The answer here is actually going to be 5. Because 5 times 5 times 5 equals 125, right? That's the reason, that's why that works, right? This being 5 to the 3rd power. Right here we have 16 to the 1/4. That's asking us for the 4th root of 16. What number multiplies by itself 4 times to get us 16? Well, turns out this answer is 2, because 2 times 2 times 2 times 2, right? 4 of those all multiply together equals 16. Moving forward here, 9 to the negative 1/2 power. This actually requires a couple steps. First, negative exponent. right? So we throw it in a fraction, 1 over 9 to the positive value of that exponent, so positive 1/2. 1/2 is regular old square root. So this is equivalent to 1 over the square root of 9, which equals 1 over 3. Right? Square root of 9 is 3. 3 times 3 is 9. And then our last one that we haven't talked about yet, 32 to the negative 1/5 power. Very similar process here. In fact, we've already sort of done this problem, but in a slightly different way. Since it's a negative exponent, we can rewrite this as 1 over 32 to the 1/5 power, right? A 1/5 power means to take the 5th root of 32, 5th root of 32. Up here, we already saw what that is. It's actually equal to 2. So this is 1 over 2. That's because 2 times 2 times 2 times 2 times 2, 5 of them would equal 32. Right? 2 times 2 times 2 times 2 times 2. 5 of those all multiply together gets us 32. All right. We're going to go ahead and stop this as part 1 right there, and I'll pick this up again in part 2.